The sign of a function. Now, we can always put the terms of an equation on the left. So for example, if you have x cubed plus 1 is greater than or equal to x squared plus x, you can rewrite it as, with everything on the right hand side. So when we do this, it reduces an equation to one of the following forms. It's that f of x is less than 0 or less than or equal to 0, or that it's f of x is greater than or equal to 0, or it's just greater than 0. So when we solve an equation, so when we do this, the whole idea of solving an equation just becomes of, well, whereabouts is the function positive or where is it negative, okay? So a function can only change from being positive to negative in certain spots, okay? And that is where it crosses over the zeros, so here and here, or when there is a jump or a discontinuity between two of the points, okay? So obviously at the point F, that discontinuity there, both of them, so this graph, it's going negative, but then when it does its jump, it continues being negative. So that discontinuity has the same sign, but this discontinuity over here, okay, so when it jumps down, it's jumping, so when it comes from here, it jumps down and it goes to the negatives, okay? So discontinuities can change the sign, but also at the zero. So when a graph, it comes down, it comes down, it comes down. So when it swaps through to 0 and it keeps going, then it's going to change its side. So it's going to come, so it's all positive up in this area here, and then it goes to the 0, and then it becomes negative. Okay, then it crosses over here, but this time again, it doesn't cross back over, it continues being negative. Okay, so that is how we determine whether that part of a function is positive or negative. Is it just in the positive area or is it in the negative area? Is it greater, or is y greater than 0, or is it less than 0? Okay, so that's how we work that out. So a table of signs. To examine the sign of a function, draw up a table of signs using test values that, well, it says dodge here, but that are around any zeros or discontinuities. So basically, instead of doing a table of values, okay, we don't actually care about the value. We just care, is it positive or is it negative? Okay. And so with that, we've got solving polynomial inequations. So to sketch polynomials, you only have to test values around the zeros, as they do not have any discontinuities. Okay, so you only have to check around the zeros. And we can use a simple table of signs to do this. Okay, so when you are actually sketching these, it is literally just a sketch. It doesn't have to be exact. It just has to look somewhat like what the thing's going to be. And then solving inequations involving discontinuities. When a function is discontinuous or has discontinuities, the method is the same, except that the test values now need to be based around the discontinuities and the zeros. So if there is a discontinuity, you have to include that as well to see what's happening either side. And so we'll look at that in a moment. Now it says over here for polynomial inequations or inequations involving discontinuities, it is not necessary to draw the graph, but is useful to have a picture to visualize where the values were at. Okay. And so with that, let's do a few examples. Okay, draw up a table of signs for the function y is equal to x minus 2 times x minus 4 times x minus 5. Now, we already know what the zeros are for this equation. Okay, so when is this equation is equal to 0? Well, it's when x is 2, x is 4, or x is 5. So what I'm going to do is I'm going to draw up my table of signs. Okay, I'm going to have x and I'm going to have y in this case. Okay. Now I know that my table of signs, all of the zeros are going to be in between two numbers that aren't zeros. Okay, so we know that 2, 4, and 5 are zeros. Okay, and then we need to check signs either side of that to see whether, on the left-hand side of the 0 at 2, is it positive or is it negative? So I'm going to pick some numbers in between these. So 3, 4.5, and let's say 10. Okay. So what we're going to do now is we're going to substitute these values into the equation, but we already know what some of these are. We know that 2 is going to give us 0, 4 is going to give us 0, and 5 is going to give us 0. Okay. So we only need to check what happens on either side of those. And remember, we don't care about what the number is. We only care if it's positive or negative. Okay, so if I substitute 0 into this, I get 0 minus 2 times 0 minus 4 times 0 minus 5. So 3 negatives multiplied by each other. So it's going to give me a negative answer. So my answer there is negative. So my value or my sign left of 2 is negative. Now for 3, so putting 3 in, we get 3 minus 2, which is 1. 3 minus 4, which is -1, and 3 minus 5, which is -2. So 2 negatives and positive, multiply them together, it gives me a positive. Okay, the next part is 4.5. Now 4.5, if I put in there, I get 2.5, 0.5, and -0.5. So 2 positives and a negative make a negative. And 10, putting 10 in there, well, positive, positive, and positive, okay, because they're all above that 0. So all those values are positive. Now, that's part A. Now we need to state, well, where is the function positive and where is it negative? Well, we know that it is negative when x is less than 2. So when x is less than 2, it's negative. So negative when? So negative when x is less than 2. We also know it's negative between the 4 and the 5. So between the 4 and the 5, okay? Now we know this thing is positive when it is, okay? So in this case, we don't want the values exactly. We just want to know where it's positive and where it's negative. So if it's 0, it's neither. Now we know it's positive when x is greater than 10, okay? Because we know over here from this 10 over here in the last bit. So when it's bigger, oh, not when it's bigger than 10, sorry, when it's bigger than 5, okay? Because 5 is our 0, so any number that's bigger than 5 will give us a positive value. I just use 10 as our placeholder. And we also know that between 2 and 4, x is also positive. So there are all my values for when they're negative and positive, and that's part B. Now part C is to solve the inequation x minus 2, x minus 4, and x minus 5 is greater than or equal to 0. So when is this function greater than or equal to 0? Or in other words, when is it positive? And we know it's positive when, okay, so by solving this inequation, we know it's positive. So we know that x minus 2, x minus 4, and x minus 5 is greater than or equal to 0 when the function is positive. So now the question just becomes, well, when is the function positive? And we've already know that. We've written it up above. So therefore, it's when x is greater than 5 and x is between 2 and 4, just like that. Now, the reason why we do our table of signs is to do the last part. So we're going to confirm our answer by sketching the graph of the function. So as I said, it is just a sketch. It doesn't have to be perfect, but it still has to be pretty good. Now, we know our zeros are when x is equal to 2, x is equal to 4, and x is equal to 5. So here are my zeros here. So basically, my function is going to go through the zeros at those 3 points. Now, we know that it's negative below 2. So anything to the left of 2, my function is going to be negative. And I know that anything greater than 5, my function is going to be positive. Okay, so it's going up in that direction. Now, between 2 and 4, my function is positive. So what's going to happen is something like this. And between 4 and 5, my function is negative. So it's going to go something like this. Okay. Now, part C asked us, when is it greater than or equal to 0? So when's this function greater than or equal to 0? Well, you can see that these parts here, my line is above the x-axis. Okay. And so that just concludes, more formally, that my function, so this cubic function, is greater than or equal to 0 between 2 and 4 and 5. Okay, so you're just looking for when is it bigger than the x-axis. Okay, example 2. Okay, solve x cubed minus 1 is greater than or equal to x minus x squared. Using a table of signs, then confirm your answer by drawing a graph. Okay, so basically we're just going to do the same as what we did before, but it's not going to step us through it. So we're going to start off with our equation, x cubed minus 1 is greater than or equal to x minus x squared. But this time we need to actually move everything to the left-hand side, okay? Because we want it to be greater than or equal to 0 or less than or equal to 0. Some form where it's a function is equal to or one of the inequalities of 0. So moving everything across, we get x cubed, the x minus x squared becomes positive x squared, x becomes negative x, and minus 1 stays there, and that's greater than or equal to 0. Okay, so now we say to ourselves, well, what do we do next? Well, I'm going to factorize this, okay? So factorizing the first bit, x cubed and x squared, X squared is in common, and that leaves me with x plus 1. Minus x and minus 1, well, the common factor is x, negative 1, so negative comes out, and that leaves me with x plus 1 on the inside, and that's greater than or equal to 0. Okay, factorising further, x squared, so x plus 1 is common to both of these, and I'm left with x squared minus 1 on as the leftovers is equal to 0. But we also know that x squared minus 1 is the example of the difference between two squares. So we're left with the x plus 1 at the front, but x squared minus 1 becomes x plus 1 and x minus 1, which is greater than or equal to 0. And then we can rearrange x plus 1 times x plus 1 times x minus 1 as x plus 1 squared, lots of x minus 1, which is greater than or equal to 0. Okay. So this one only has 2 zeros, okay? Well, if you look back up into this original one before I simplified it a bit, we have zeros so x is equal to 1 for the last bit, and we also have them at x is equal to minus 1 and x is equal to minus 1. So it's actually a double root at x is equal to minus 1 because two parts of the equation land there. Okay, so it is not actually necessary to write down both of those. So the zeros of both of these are just these ones here, so 1 and minus 1. So what I'm going to do now is I'm going to draw up a table of signs, okay? So my table of signs, I need to have my zeros, so negative 1 and 1, and I need to have something either side of those zeros. So negative 2, 0, and 2 will work perfectly. Okay, filling in these values now, I know that it's 0 at negative 1 and 1. If I put 0 into the equation above, I get 0 plus 1, okay, which is 1 squared, which is just 1. Lots of 0 minus 1, which is negative 1, so a positive times a negative is a negative. Okay, putting 2 into there, I get 2 plus 2, which is equal to 4. Okay, 2 plus 2, which is equal to 4. Sorry, 2 plus 1, which is equal to 3, squared, which is equal to 9. And I put 2 on the other side, and I get 2 minus 1, which is negative. Negative. I can't think for the life of me. Which is negative. No, it's positive 1, sorry. So positive times a positive, which is positive. And then my last bit, negative 2 goes in, I get negative 1 squared, so that's a positive. So any negative becomes a positive here, so it's positive in here. Minus 2 minus 1, which is minus 3, so it's a negative. Positive and times a negative make a negative, so it's a negative there. Okay, so now I need to sketch the thing to confirm. Oh, well, firstly, let's answer the question. So solve the equation. So our equation, remember back up here, let's solve this one here because all of these are equivalent equations. So x cubed plus x squared minus x minus 1 is greater than or equal to 0. So when is this thing positive? So positive when x is greater than 1. Okay, so we don't include that bit there because remember we're looking for when it's greater than, when it's greater than or equal to 0. So it's greater than or equal to 0 at x is greater than or equal to 1, so because we're including the 0 this time. But where is it also equal to 0? Well, it's also equal to 0. It's also equal there at negative 1, okay? So it's positive at x is greater than or equal to 1, or when x is equal to negative 1, okay? So again, we can confirm this by sketching up a graph, okay? Let me draw a better one than that. Okay, so we've got this here. Okay, we know our roots are at negative 1 and at 1. Okay, and we only care what's happening either side. So I know when it's greater than, so when it's less than 1, when it's less than negative 1, okay, it's negative. Okay, but when it's between 1 and negative 1, it's actually also negative. So it's going to go in like that, but like obviously more straighter. Geez, I can't seem to draw this one. And then when it is greater than 1, it's positive, so it's actually going to shoot up like that. Okay, so when is this function equal to 0 or greater than 0? Well, it's equal to 0 at this point here, and this point here, and it's greater than 0 at this point here. Okay, so those are all the values that make this inequality true. Okay, examine the sign of y is equal to x minus 2 over x minus 5. So all we're going to do for this one is we're going to work out, well, what's the sign for this thing? So, you know, where are the discontinuities and where are the discontinuities and where are the zeros, and where are the, and is it positive or negative? Whereabouts is it positive or negative, I should say. So we're going to start off with drawing or working out where the, so we're going to start off by working out where the asymptotes are. So remember, an asymptote is where this thing doesn't exist. So the discontinuity for this one. So where can't I have, well, what value can't I have that doesn't work? And we know that x in this case cannot be equal to 5. As if it's equal to 5, 5 minus 5 on the bottom of a fraction is equal to 0, and I can't have it on there. Okay? Now, the other part is, where is my 0 for this equation? Okay, so when is this thing equal to 0? Well, it's equal to 0 when x is equal to 2. So zeros when x is equal to 2. Because if I substitute 2 into this equation, okay, I get 0 on the top and I get something on the bottom, okay? So discontinuity, I can't even say the word now. Discontinuity at x is equal to 5, okay? So x can't be equal to 5, so discontinue at x is equal to 5, and 0 is when x is equal to 2. So when we go to do our table of signs for this one, okay? So I'm going to have my x and I'm going to have my y. Now when I put in my values this time, okay, I'm going to put everything in, and I'm going to put, this time I'm going to put my 0 where it's 2, and I'm going to put my discontinuity. Now, the thing that we put for a discontinuity is just a little star, okay? So that just verifies that that's a discontinuity. There's no sign there, and it's not 0 either, because, you know, there's no value that makes that equation true for that value of x. Now we need to pick some values to put in either way. So I'm going to pick 0, 3, and 6. Now we're going to substitute those values into our original equation and see what happens. So at 0, so x minus 2, so negative 2 over negative 5, well, that's just negative. Okay? Oh, sorry. A negative and a negative, that should be positive. It makes it positive. Okay, putting 3 into there, I get 3 minus 2, which is 1, over 3 minus 5, which is negative 2. So positive divided by negative is a negative. And 6 in the top and 6 in the bottom gives me a positive on top and a positive on the bottom. So that's a positive there. So all we need to finish off is just state y is positive. Okay, so y is positive when x is less than 2. Okay, so it's not including because it's 0. And also when x is greater than 5. Y is negative when x is between 2 and 5, okay? Not including. So because it's between the 2 and the 5, so the 0 and discontinuity, everything's going to be negative in between those, okay? And then it's going to be positive for the rest otherwise, okay? So that's how we just examine the sign. It's just by looking, well, where's it positive and where's it negative? And we can use a table of signs to do that. Okay, last but not least, we're going to solve 8 over x plus 6 is less than or equal to negative x using a table of signs. So there's a few ways that we can do this one, but first we need to move everything to the left-hand side. So we're going to go 8 over x plus 6 plus x is less than or equal to 0. Okay, and so we're going to set up this equation like this because we want it to work. However, we know there's also a discontinuity somewhere in this graph. So remember, we're looking at the original graph. There's a discontinuity, okay? So we'll start with that. The discontinuity when x is equal to negative 6. Now, why would that be? Well, we know that because if I was to substitute negative 6 into this equation, I'd get a fraction with a 0 on the bottom. That doesn't work. So for my table of values, I need to make sure that I'm actually including this negative 6 here because that will actually determine some stuff about it. Now, let's solve this equation so we can find some zeros. So this is an equation. So I'm going to ignore the right. I'm just going to simplify the left-hand side. So we're going to get 8 over, or plus, so we're going to make a common factor, so x lots of x plus 6 over x plus 6 is less than or equal to 0. Okay, so to do that, I'll just do that one quickly. So 8 over x plus 6. So remember, x is the same as x over 1, so multiply the bottoms. So 1 times 8 is just 8, and then x plus 6 times x plus 6 over x lots of x plus 6, like that, which is less than or equal to 0. So 8 plus x lots of x plus 6 over x plus 6 is less than or equal to 0. Okay, multiply both sides by x plus 6 now, and you just get 8 plus x lots of x plus 6 is less than or equal to 0, okay? So just remove that because you literally can just times both sides by x plus 6. 0 times anything is just 0 anyway. Expanding that side out, we get 8 plus x squared plus 6x, which is less than or equal to 0. I'm going to rewrite this as x squared plus 6x plus 8 is less than or equal to 0. Because now we can factorize it, and it's quite an easy one. Two numbers that multiply to give 8 and add to give 6. Well, that's just when x is equal to 2 and x is equal to 4, sorry. So, zeros are at x is equal to negative 2 and x is equal to negative 4. Okay, so now I can do my table of signs that I've got that done. Okay, so my table of signs. So I need to use negative 2 and negative 4, but I also need to use this negative 6 where this discontinuity was. So, table of signs, and I'm going to need a lot. 1, 2, 3, 4, 5, 6. 1, 2, 7, 8 in total. So I'm going to put in minus 10, minus 6, minus 5, minus 4, minus 3, minus 2, and 0. Remembering I have a discontinuity at x is equal to negative 6, and my zeros are at negative 4 and negative 2. So with that being said, let's work out what the sign is of these other ones. So I'm going to go back up and you do this original equation up here. So I'm going to just remove that for now. Okay, so I'll just use the 8 over 8x plus 6 plus x is less than or equal to 0. So let's start off with 0. Let's put 0 in here. So 8 over 6 is just positive plus 0, so that's just positive. Putting in negative 3, we're going to get 8 over a positive plus a negative number. So 8 over 3 plus 3 is going to give us a negative. Okay, so negative for that one. Putting negative 5 in, and that should give us a positive. And putting negative 10 in will give us a negative. So you can just verify those using a calculator. Okay. Now, what we're going to do is we need to solve it for when it is less than or equal to 0. So let's write because we want less than or equal to, i.e., so in other words, where y is less than or equal to 0, we are looking for when the function is equal to 0 or it is negative. Okay, because less than 0 just means it's negative. Okay, so where's this thing negative? So in this case, it's going to be when x is less than negative 6. Now, I'm not going to include negative 6 in this one because there is a discontinuity at that point there. Okay, so when x is less than negative 6, that is when it is negative. Now, it is also negative between negative 4 and negative 2. So x between negative 2 and negative 4. Okay, but because we also want the values where it's also equal to it, it's also equal to them at that point there too. So when x is less than negative 6, the function is negative, and when x is between negative 4 and negative 2, it is less than or equal to 0 as well. And that is the final answer, so that's all that we want for that part. Okay, so with that being said, that's the examples for today. Hopefully you guys will make the most of it, and I'll see you in the next video.